Good morning, good afternoon, distinguished colleagues. I'm happy to welcome all the participants at the final session. This session for those who are really involved in the issues of digital transformation of enterprises. You'll receive 5 presentations on the use of AI to improve operational efficiency. The first one to speak, I invite Victor Portnov, Product Director, Conundrum Industrial Limited. Colleagues, good afternoon. I hope you can hear me. I am Victor, and I would like to make a presentation on optimization of industrial processes, the products and examples of products that we are developing. And I'll start with the history of a company, like an introductory, where a company that developed software for optimization of key industrial processes of mining and metallurgy complexes. We have more than 50 employees. We are a UK-based company. We are quite diversified in terms of specialties. Mostly we have specialists in machine modeling, data scientists, and specialists in mining sector, and developers who create professional and safe softs. The examples of our partners you see on the slide: Anglo-American, Nornickel, and so on. When I was thinking on how I'll develop my presentation so as to demonstrate possibility for improvement industrial and operational processes, I decided to make some divisions. I would like to start with the following. The question is what we actually implementing. We can implement consulting solutions, some vertical optimization algorithms. We can modernize the equipment. We can deal with wide process of digitalization, and it can be done differently. We are developing the platform allowing for establishment of optimization-based solutions, not only by ourselves, but also we provide ready solutions based on our platform that are devoted to the main processes of concentrating mills. And now we are expanding these projects to para and hydro metallurgy. These stages include crushing, flotation, and dancing. A little bit about platform. What are the blocks that should be included in such solutions that could become a uniform infrastructure for working with such algorithms of different types, including in-house and the outcomes of internal data scientists and developers, and that could be the results of third-party vendors. First of all, we are working with industrial data that includes some standardizations, compliance with some global standards with regard to description of the data present at the prices. It is quite a big set for establishment of different algorithms based on machine learning, based on already applied practices and such known methods as in clear logic and PC, modeling predictive control methods, including modern ones, which are all the time updated and which are of the cutting edge of data science, including machine learning, from the point of view optimization of such industry. As I have already mentioned, it is prepared solutions that are kind of presets with significant experience, possible to implement and fastly deploy at different facilities. They include algorithms and significant volume of expert knowledge and rules special algorithms that we know to be capable to work with this data, special hybrid models, combination of physical models and models based on real data that are actually robust or sustainable from the point of view of variability of the data available at the plant. If we come for finding and we want to optimize it. Sometimes we have granularity, or sometimes it is not available. Sometimes it is possible to control mill. Sometimes it's not possible. Sometimes density measures provide adequate data, and sometimes not. And well-considered architecture of these solutions allows fast deployment and testing and demonstrates statistically important outcome as a pilot. A statistically important outcome is a very important element that proves that the plant's CEO technologies controls the outcomes of an experiment and understand why the result is 1.5% grade and that the sampling is not distorted and that experiment was set up correctly. Visualization is different also. Mostly it is provided to its final user operators, but also to technologists and subject matter experts who are dealing with plant optimization, and for the engineers design to set up and to see how the data look and how the scheme of the plant looks like. An important factor is that during the year the price, a lot of modification can happen, and complex solutions are based on topology or scheme of a plant. If recirculation was not present and we add it, and the solutions that learns from historic data should know that this modification happened as enterprise, and creating versions of these changes, creating versions and adding sensors and accounting of entire balance of months and its changes with the time. This is a very important component for construction of such optimization solutions, even if we are not talking about soft sensors or virtual sensors or kind of subproducts that are used in these decisions. And the most important thing is administration and safety. If there exists a platform or algorithm on the platform, it should be compliant with industrial safety criteria. If we have a common sense of a coding, they make certain solution and they have somehow placed on a server, they place it on a Docker, and then the solution stops working and they ask us why it does not work anymore. And this is a difficult situation that should be controlled. We guarantee that the solutions that will be delivered that pass the audit for being placed on our platform will be safe and they will be usable. If we summarize how we position our platform among certain sections and who is doing that, some common analytical platform like Google, email, Microsoft email, and so on and so forth, some vertical solutions that visualize the amounts at flotation or at crusher or at the mills, and consultant would come and propose certain solutions based on expert experience and classic expert EPC systems that exist since 1980s. In this case, we have 6 main areas where we can make comparison. If we're talking about industrial specifics, it's very important that all the algorithms that we produce, solutions that we use, all of them are based on good understanding of the structure of industry, what is important, what is not, what are the real situations the operators, mill operator, flotation operator are facing based on a huge number of different cases. And when we started using common solution, we would arrive to certain restrictions and people would have to drill down into specific point-to-point optimization. It's a wall for vertical solutions and for consultant. When at the end of the day, we need to have an opportunity to orchestrate solutions that would optimize the entire mill, starting from primary crushing or starting from the order of geologies up to tailings denser and up to orders to the port or to the plant. So safety, it is a critical since if you are not an advisor, but if you do management and if you control bit controller, your solutions and decisions should be safe. Openness. Openness is a very important aspect for big companies. When you are a big company, when you have a team, and if you would like to become an agnostic vendor, and if you would like to operate with different vendors, and if one vendor demonstrates the better quality and you have a capability to exchange, but geological exploration is also important on top of fabrics. Then you have to develop an ecosystem where components can interact so as to avoid bottlenecks. When solution has been made that cannot communicate with anyone else. So we provide this openness, we can get integrated with internal solutions, and we can provide API, SDK, including the ones for third-party vendors who place their solutions on top of our platform. Efficiency. It's very straightforward, and support is also a very important aspect. It's creation of new versions, a second, third, and fourth lines of support if something happened. It's permanent update of the platforms. It is training of the employees, and in principle, some permanent additional training and adaptation of the model so as to maximize the effect. That was about platform. Now I would like to share about several cases we have implemented. The first one is about crashing, and we have quite comprehensive contour, primary, secondary, and PGR, and so on. Here we had a lot of problems, and here APC system was installed, but it cannot cope with optimal steady states considering a long period of time of or passage through all these three contours, and they have big interim storage facilities, and all the changes happening with the ore should be considered so as to develop optimum setups, optimum installation for the next processing steps. Actually, it was end-to-end optimizations that allowed to add additional productivity to the contour in the amount of 3%. The next one is milling, a control of MSI, including feeders of coarse crushed ore. And in accordance with the classics, we decrease the variability and we have an opportunity to raise this rate.
We can reduce variation rates and also to obtain an answer when we can avoid overburden and what time we can change it, because we may focus that it will not result in overrate of the mill. The next level of flotation is the correction with the aeration, chemicals, and other levels. These are our cases, our examples, and here's what we got as a result. Colleagues, if you have any questions, I'll be happy to answer. Thank you, Victor. If we have time, we will have a Q&A session. The next speaker is Andrey Tyan, Director, IntelliSense Lab. Good afternoon, colleagues. My name is Andrey Tyan. I am Director of Kazakhstani division of IntelliSense IO. It's a UK company based in Cambridge, and our company is dealing with the development and introduction of AI-based solutions for optimization of the processes in the mining sector. Let me say a couple of words about our company. We have more than 100 employees in our company, and we focus all our efforts on this area, and more than one-third of our employees are professionals from the mining sector. Other personnel include the IT specialists and data scientists, and we offer solutions from professionals in mining sector to professional, offering these professionals in mining sector. Our clients include BHP, Anglo-American, Kalapasta. Altynalmas is our client in Kazakhstan, and we have about 27 ongoing projects at the moment. Our portfolio includes, and what makes our products unique. It's a brain sub, it's a database of AI, and this platform is built on the following principles. The main block of this platform covers the work with data. The system collects the data, classifies the data based on categories poor, good, incorrect. The second element includes data processing, which includes statistical analysis, neural network, multi-layer network or bias network for backup tasks, virtual sensors development, or if a client has its own models, they can be integrated. Another element is responsible for visualization function with generation of charts, diagrams, or reports, depending on the needs of customer. The platform has a wider functional, which allows to enable a movement of data through the channels, which includes mass relating and volume relating characteristics. But also we can trace concentration of metals, chemicals, density, and so on. In addition to that, we have a data confirmation and verification elements. I'm sure you know that it is a big challenge for the mining company, for the mining sector, and they have to find a solution for so-called single source of data, reliable and accurate. On the basis of this platform, we build apps for optimization of different processes. For example, crashing function, mining storage facility operation, and many other operations. Here is a slide with our clients. Let me now move to the case that we wanted to present today. And this is the project which we launched in January 2020. This is an optimization of crashing site for Altynalmas in Kazakhstan. We optimized the crashing cycle for the wet mill. The client had a problem. On a regular basis, the mills had to stop to take some measurements. Each suspension takes time, and we had a task to build a virtual sensor to provide data on the volume of the mill performance, of the mill, in order to provide early identification of the hazards or risks when the mill is overloaded. So we built a movement model with virtual sensors. I'm going to show you how these models work. Here is a scheme of the crushing cycle. Materials from the cone of ore comes to the mill. Then there is a second cycle, the second phase of crushing, and further it goes through the phase of leaching. And I don't know if you are able to see, but here are the points where direct metering data is collected. In fact, these are conveyors that measure the weight of mass, of ore mass. And there is a line with supply of technical water where the volumes have to be measured. And then there is a dot which stands for a virtual sensor. But in this dot, there is nothing. It's just virtual meter, virtual sensor, which takes measurements of the amount of water spent for treatments. But if you know how much water you use, it's not difficult to calculate the mass volume. But the problem is not about the metering devices. We applied a formula to create a virtual sensor. It is a very simplified example, but the mill has such parameters as JB, which stands actually for the mill's performance. And the model is very complicated. It's not about one formula. It involves a lot of formulas, computations, and neural network. And virtual meter is also the time of passing the ore through the mill. Of course, it's non-existent. It's virtual. And the green dots stand for real and virtual sensors monitoring the process of movement of ore through the belt, through the mill. The next is the model of the downloads volume of balloons. This is an information panel, and it depends. For technologists, it is important to know the percentage of ore, for example, 16% or 13%. In order to be able to take such measurements and data, it is necessary to stop the belt, to use the real devices to take measures, to take the data from the belts. And during this period, and it takes 2 times a month to take such measurements, and each mill stop lasted about 15 minutes, which is waste of time, and so on. With the virtual sensor that we created, we built it for our client, and there is no longer need to stop the belts and to take these measurements. The second to the left, it shows the necessary measurement parameters. There are some other parameters that have to be measured as well. For example, distribution of balloons in the belt of the mill, and so on. Our next model is the model of footage of the footage deterioration. In total, we have 20 blocks as such, and for each block, we built a virtual sensor to identify its status. It also allowed us to measure the balance resource in percentage, in tons of processed ore, and the client has all these details in an online format, which allows the company have a clear understanding of the status of footage and to put some maintenance and repair works and equipment replacement works in the plan. The next model is the model to focus overloads of the mill. It's a situation which is hazardous, which is risky and hazardous because the engine deteriorating, the processes takes place faster than it is desired, and you have actually to turn on and turn off and turn on the equipment. The process is inert by nature. Therefore, we had a client's request to enable a system that would alert you a couple hours before the critical parameters are achieved. So before it's actually a hazard, an operator can manipulate and stop water supply and avoid it or to mitigate the consequences. This system was launched into industrial phase in January 2020. And in the end of 2020, together with the clients, we calculated economic effects, which allowed to save 1,300,000 US dollars. So it was a worthwhile investment. Now we continue to improve the crushing measurements. We add more functions such as optimization and flotation. Thank you very much. Our next presentation is dedicated to a very interesting topic, digital kern, and Levon Kirakosyan, the floor is yours. Good afternoon. Before I start, because our product is intended for geologists, let me take this opportunity and express and congratulate you with your Professional Geologist Day. Coming back to the problem that we are solving, many companies which work with drill slur, they use two methods: lab tests and reports, descriptive reports provided by geologists. When we should remember about a joke, if you have two geologists, you will have three opinions. So we try to find a solution for that. It's pretty easy. We take pictures of the drilling current and try to define geological and geomechanical characteristics.
With that, we optimize indirect cost for the process and increase the systemicity and the quality of such descriptions. What we can do in principle and how it works. The pictures themselves are inside of algorithms on neural network. Virtually, we take the code from the boxes and we are capable to identify such things as the leader types, intersections, geomechanical characteristic TCR, RQD. The part of the algorithms are universal, and some algorithms have own specifics which are tailored to particular client. As a methodology of identification of such characteristics change depending upon the company, and we can tailor of a solution appropriately. And the second area we discovered for ourselves, and our first algorithm learned to work, this is a surveys of the outcomes of hyperspectral surveys. It's not a business practice, as this equipment appeared quite recently, and I inform you what is that. Hyperspectral camera is a camera that is capable to emit waves of different wavelengths and survey the objects in this light. If Actually, it works as follows. Why we can see that the water in the sea is blue when the daylight reaches the water, then red color is absorbed and blue color is reflected. That is why we see water as blue. It is the specifics of daylight and the water. We use the same principle in hyperspectral survey, but we use the emissions of daylight and ultraviolet and infrared emissions, so with a very short sample rate, and we get 3D cube of different images. As the objects are absolutely different, in this case we are talking about minerals, and their behavior differs in these wavelengths. And the first thing that we can do with this method, we can see better ore mineralization in the rock, and we can instantaneously identify ore mineralization and understanding what do you have, and we have specialized tables that explain which minerals occur in which range of horizons. And if we take analogy to remember Avatar film in the evening when you can see everything that is invisible previously. And another example that I would like to discuss today that we managed to do together with a company dealing with iron ore mining. They had one problem. They faced mixing of ores from different deposits before concentration as ore were of different qualities. They had to understand how much ore from particular deposit reach the conveyor to control the process of ore mixing. It appears that with certain processing in hyperspectrum, it was possible to see that the rocks from different deposits looked absolutely different. In the lower part of the slide, one rocks are green, other rocks are red, and the third rocks have impregnations of different color. Actually, these are different deposits. How it happens in real practice and how it exists. Usually in the mine, one would identify the area where core copy photographed, and it is just you can use any camera of 20 megapixels. It would be enough for certain tasks, and the light is ordinary, and then these pictures are sent to our service. You can send it by mail, and we do the analysis and provide the outcome. At the first stage, we started with that some companies take pictures of core using telephone, and within this quality of pictures it is possible to identify the parameters. From the point of view of quality, we compare the outcomes of our model with laboratory results, and we see very close results between the two, and we see that our clients can trust the outcomes that we produce with our methodology. On this slide, you see the example of an interface, how it may look like. There is nothing special. These are boxes, and every box, every meter of core in a box is a card. When we get it, we enrich it with the characteristics that we had agreed with the client. And also, it is possible to upload this data to various formats so as to use them in different GIS systems, Micromap, Leapfrog, and so on. I would like to talk about the experience of implementation of the system in one of the client premises. We analyzed more than several kilometers of drilling cores, and now we saved about $5 million on laboratory tests, and we improved the quality of resources model that the client possessed. And in this particular case, it happens that we identified, thanks to more intensive analysis, of course, we identified more samples, and we identified more places of ore body, and the client made additional exploratory drilling and confirmed the outcomes, and it resulted up to additional $150 million profit. From the point of view of the process, usually we have two stages. At the first stages, we set up our models for particular deposit. This step is obligatory, but for this we would need some minimum number of pictures, from 50 to 100 pictures, that would allow us to set up a system and tailor it to particular client, task, and rocks. And starting with this model, we can produce first industrial outcomes and gradually increasing the number of recognizable characteristics, quality, and accuracy that we can predict. From the point of view, and we are often asked, is it a cloud-based solution or not? And also we receive the questions about data security. In this case, we have three options. We have the option of cloud service, we have hybrid option. One, in the cloud we have only algorithms, the data kept by the client and we do not have access to them. And the third option, when we can establish a local installation, it could be some overhead costs related to support of update of all the model, but we can still do that. That is what I would like to deliver. Our contacts are available and we are prepared to respond to your questions at any time. You're welcome. Thank you. Thank you. The next person to speak is Rafal Valecki, the head of strategic project management, Datamine. Good evening. I'm Rafal Valecki. I'm an employee of Datamine, where I deal with big strategic project management. I'll switch into English in a minute, but I'd like to say, if you would like to talk on this topic or ask question in Russian, I will be available, and it's quite possible.
That's much more comfortable for me to discuss technical aspects around the sales and marketing when selling commodities on English. So sorry for that, but I will use this language. Okay, so on to the subject. We'll talk about money, really. Every mining company is digging stuff out of the ground. That's the product which we are producing, which we are transporting, processing, preparing, and then selling to the customer. But we do it for money. So really the other side of the equation, so how we sell it, who do we sell it, how we contract it, is equally important, if even not more important. So when you look at what my market is, we have like two sides of it. One of it is sales and marketing, which is taking care about money, and the other one is about logistics, which is really taking care about how the product is being prepared. Joining those two worlds is a key to success, and this is what my market software does. So how it really works. There are different companies using this kind of a solution. What we call commodity traders. There is a class of companies which is really the most complicated example for our software, because those companies are buying stuff very often from different sources, from multiple sources. They are then transporting it, shipping it to different part of the world. They are storing it. They might be blending it actually to get the better product and selling it to the final customer. So basically we have all the stages of the process which needs a full control when it comes to the product, as well as the financial aspects of all the transactions which are inside the single entitlement. So that's the most complicated example. We also are working with the mining companies which are producing stuff. They are usually not buying anything, but they are producing and selling. On the other side, you might have companies which are buying stuff but not selling anything. A classical example is power station, which buys coal and using it to produce the energy. So there might be different challenges and different companies using this kind of a software and this kind of a solution. But when you look at that, commodity traders is what is the most complicated one. So when you look how those commodity traders work, that's what you see on the screen. They have trading, they have traffic, they have hedging, and middle office, which is taking care really about securing the financial transactions and dealing with the risk. There is a financial controlling, and of course finance accounting, which is really going slowly to the other system, which is connected, very tightly connected to our market system. So this class of the system is called commodity trade and risk management, and this risk component is also very, very important, which I will try to show a little bit later. On the other side, as I said, there are mining companies which are using this kind of a solution. When you look at the process, how mines work, what is the life cycle of a classic mining company, you have those on the left side, which is explore, define, construct. That's something which is happening at the very beginning when you open the deposit. And then in the cycles, you are actually going through the mining, processing, and then trading, so selling your material. Right? So we, as mine market, are dealing with the right side of the equation. Starting from the moment you actually get your product in the mine, processing it and then selling, we can track everything which is related to this, quantities, qualities, and related to how the financial result will look like. All the blue ones, when you think about, say, overall level of the processes which are connected to those stages of the mining life cycle, all the blue ones are covered by mine market system. So how does it work? Really at the very beginning of the process is getting how the logistics of your product looks like. And a classic commodity trader, you're probably buying something, you're transporting it, you store it somewhere. You might be using ships to transfer it to the different part of the world. You might store it again, you might blend it to get a better product, transport it again, and then dispatch to the customer. So all of this needs to be cached in the system. How this process looks like, including the control points which are marked with those lap glass in a blue color. That's the point where you're actually checking if you have exactly what you need. So basically taking your samples and evaluating your product. On each stage of this process, you're dealing with different companies. So one of the things which is the core of the system capability is storing those companies. Again, in all aspects, physical, so who they are, where they work, but also financial, so all the credits, credit lines, all the dues, invoicing and everything, bank accounts, what is connected with it. So everything is stored as your counterparties you're dealing with in the system. And what is the core of the system is really contract management. Every time you sell something, every time you buy something, you have a contract which is describing all the peculiarities of your arrangement with your counterparty, your seller or buyer. There are legal ones, there are general ones, but there are also technical ones related to the qualities of the materials, penalties or bonuses. All of this is written in the language on a piece of paper, which actually to allow system to work with it needs to be written in a digital format inside the system. So that's what the system does. It's quite a complicated thing which digitizes your contract into the thing which might be stored in the computer. Every type of a contract, sales, purchase, intercompany, freight contract, services contract, everything is stored because everything is contributing in your financial result. Logistics is a very important part of the equation, of course, because you're tracking the material and evaluating it at each stage of your process. So many different possibilities here. First in, first out, last in, first out. That's a classic one when you're stacking it from above or taking it below, or stacking from above and taking from above. Might be weight average one, which are most common ones, or the most sophisticated ones like 3D stockpiles. And then when you talk about bulk materials, when you talk about warehouses, we have the discrete materials. When you think about gold companies, they are producing gold bars, which are discrete materials which needs to be stored and shipped. So that's also possible inside the system. And then logistics actually. So when you store, fine, but then you have to deliver it to the customer. How you do it, or how you move it from one point to the other point, many different methods, many different things you can use actually to move your material. When you think about the big companies, things like coal, commodity traders, they're using they're shipping materials between different parts of the world. So all of this, with all the sophistication around it, timelines, demurrage times, loading, making sure that the ship is loaded properly, all of this is written in the system, as well as other transport possibilities like railways, like trucks that might be used with all the things which are related to it. So when you're sending your materials to the customer, you are doing lots of lotting and sampling just to understand the materials on the side of yours, or your side, on the person who are selling, and also on the customer side, which wants to make sure that they have the same results. And then you do the assay exchange, which is actually making sure that the final result can be used for invoicing according to the contract regulations. So those are logistic sides of it. You follow up to the invoicing based on the transactions, not as simple as it might look, that you send your invoice, who knows the business, knows that it's a complicated process, when actually it should be invoices, according to what prices. There are many different methods which are also supported by the system, but the final results are all the invoices across the transaction are being sent by the system. All of this, of course, needs to go to your accounting system. That's what we told part of the CTRM business is accounting, as any other company, but in CT and commodity trading is doubly important, I would say. So all the transactions, according to the defined chart of accounts, needs to go to your accounting system. This is the integration we're doing with many different players on in an accounting world, and it's becoming a very important part of the system. Risk management, of course, on both sides, transactional risk about changes of the pricing, but also foreign exchange of the currencies, which are also very important, with different methods to estimate those risks, and direct link to physicals. So that's a must for any commodity trader. All of this, and especially for the commodity trader, needs to be visible, transparently visible. What you buy, how you do it, what you sell, to whom, in one sheet of paper showing your profit and loss. You need to have a full control over what's happening to make sure that you're not losing money, that you're earning the money which will define. So this overall view of all your transaction, or even all the transactions you are doing, understanding your P&L, that's also very important. But we're not dealing only with the current timeline. We're not considering our transactions and building the plan over the pricing which we have right now. We're trying to forecast in the future, because the prices, the exchange rates can change. So we basically, all the transactions which are happening in the future, yes, you can imagine it's not instantaneous that you buy something and sell at the same moment. So during the time when you buy something and sell it, anything can happen. So it's very important to understand how the situation on the market can change. And for this reason, the system is connecting to the pricing sites like London Metal Exchange, getting all the pricings and all the forward curves, what we call forward curves, to let you understand how your situation might look like in the near future. And the same situation, of course, about the exchange rate. That is building this picture. For any moment in the future, you're understanding your situation, your cash situation, bidding your quotation on profile. And of course, once you have the actual transaction, you compare actuals to your estimates, and then in the next cycle, you can look at it and say, okay, we need to adjust the process, because it's not really adding up and providing us trouble. So it provides this engine to improve your estimates in the following cycles. So why this kind of a system? Why MineMarket CTRM? There might be many different things, but just four of them: life, profit and loss, full understanding what's happening. Right? So that gives you the tool to control what's happening with your materials, what is the value of your material at any point of time, how to drive this material to provide the final product according to the specification in the contract. As you can imagine, delivering something which is better than defined in the contract on a better qualities, you will lose money. If it's less or worse than defined in the contract, you will lose money too because you will pay penalties. So you are really interested to get it exactly at the defined parameters, and that system allows you to do that. Clear view of your risk, seeing all the forward curves price, seeing how the situation might develop based on the exchange with the services which are providing pricings and rates for the currencies exchange. That gives you a clear view of your risks, lets you control the costs very tightly, and least but not least, trust your data. You have all the data in one place, so you need this kind of a tool to understand how your physicals, what you have on the one side, are transferred into your financial situation and optimize your financial transactions. So if you have any questions, we are right across the door, the corridor, a company called Datamine. Please come, we can talk about the system. Thank you very much.
Спасибо.
Thank you. And final presentation from Evgeny Lyubavin, Director of LocoTech-Signal Asia. Good afternoon. My name is Evgeny Lyubavin, and I will speak on behalf of the company's TMH Intellectual Systems. We've been a strategic partner of joint stock company Transmash Holding, largest equipment manufacturing company, TMX Intellectual Systems, which develop comprehensive systems enabling effective monitoring of the trains, and also we develop drones based on AI solutions and a program of AI management for trains. A locomotive, LocoTex, is intended for non-cable transition of data, electronic systems for locomotives. We are dealing with development of control of the movement of trains and locomotives. LocoTech-Signal Asia is a daughter company of Intellectual System, and we're dealing with replication of the products for the railway sector in CIS countries. The company has partnership relationship with many companies from Kazakhstan, Timirzhally, Kazzinc, AGMK, Tashkent metallurgical plant, and Shotdan mine. For industrial companies, we offer a range of products, Control Vision 50 to enable control over the state of the train operator, Control Vision 100 Vegan Edition for visual control of the movement of trucks, and remote operation and control system, automated control of train, Control Log 200, processes for central control of locomotive movements. I'm going to speak about each of these systems.
Control of loco driver conditions. The system works on the processing of systems received from video camera in real time on the condition of a loco driver and provides signals for control of agility. So it is based on the position of the loco driver's body, tilt and position of head analysis of phase. The list of algorithms can increase after the system's learning in the course of its operation. Depending on the assessment of a condition of loco driver, the possible scenarios are possible. If the driver is absent at the workplace with the speed of loco more than zero, the auto braking is activated. If the system confirms that the driver is active, and if the system identifies the condition of fatigue, then a check of a loco driver is carried out through appropriate algorithm. After it is confirmed by a loco driver, the system goes to waiting mode for a certain time. After this time, the loco driver's condition is reassessed. After if signal is negative, then auto breakage is started. Control vision 50 is equipped with a system of self-diagnosis and informs the loco driver on the status of work. And if required, it transmits the data in a uniform data control center. The system of identification of obstacle, control vision 100, allows the following functions: identification of objects in the course of movement of loco, indirect part of the track in the distance up to 100 meters. If it is required to control death zones, additional cameras will be installed. And the classification of obstacles is classify the following obstacles: human being, rail, train, vehicle, and other objects. Identification of objects in the axis of a track by the width of the clearance of rolling stock identifies the signal liter of traffic lights and the position of track switch. Possible response on objects are breakage, visual, and audio informing of a loco driver depending upon the type of obstacles and distance to them. At stoppage, the loco driver is not informed about obstacles, and also controlled movement function is also included using special buttons. The system stops for some time responding on the obstacles and periodically provides sound systems signals to raise the alert of a loco driver. Two working modes are installed: locomotive and advancing tip mode. Automated system controls breakage depending on identification of objects and distance. In tip mode, the system provides only visual and audio warnings and alerts. The system of remote control of a local control vision 20 can have two options: mobile and stationary control point. The using of mobile point allows remote acceleration and breakage and provide information from the board to the operation point. On this slide, you see the example of mobile operation control point. Stationary control point control vision 20 has the following functions: distance control of track, radars, diesel, and so on. Transmission of video flow in real time from loco to post. Possibility to control several locos from the same control point. Visualization of local location in minimal scheme of station. A reflection of the data on the condition of the loco. The systems of remote video control in movement by cars ahead, so the system ensures visual control over the emptiness of the track, assessment of train condition of track, and this system can be used at any type of locus and traction aggregates. When shunting and is fulfilled with a speed no more than 20 kilometers per hour. This system can be used and this system operation based on images from video camera installed on the tailing car of the train and transmission of this information on loco driver display. It has appropriate resolution allowing to control the track in the distance of no less than 100 meters. The system may record video during 5 days. The key element of the system is a mobile block installed on the connection of cars by operation personnel. And then, after the operation is over, the mobile block is removed. The equipment of mobile block is fed by accumulator battery installed inside the body, and capacity of accumulator ensures the work during 12 hours, considering the load of no less than 50% of working time in all the regimes and conditions of operation. The system will be supplied in second quarter of 2022 to be installed on rolling stock of Kazakhstan and industrial companies of Kazakhstan. A system of microprocessor centralization called 20 is meant for control of devices of railway automatics and industrial railway transport control. 200 is a microprocessor accompanied system allowing connection and disconnection of routes and stations, compliance with the rules of train movement safety and measurement of independence of the systems in the conditions of electric centralization. The key task of the system is control the objects within certain part of station or district of station, always ensuring a design capacity of the station. So the system allows to control railway automatics and telemechanics at the station and ensuring connection with on-the-ground equipment. On top of the logic of centralization of a station, computing complex can be integrate the logics of the work of the automated signalization. In centralization, we have connection to internal system of firefighting, air conditioning, and lights. So microprocessor centralization is introduced into Shamkin plant and shutdown plant and is prepared for shipment to be delivered to all Malik mining concentrator. Microprocessor system of rail chains is meant for application at stations and shunting lines, at any traction, and also at rail tracks of non-general use as a system of coding of control of emptiness and busyness of the section. A control track 100 system is a part of systems of interval regulation of movement of trains of electric centralization. The system of rail chains put in operation in main line of Kazakhstan Temirjali and the railway of Latvia and Estonia. Thank you. That's all I would like to deliver. Thank you.